Thank you, Fox, for watching this session for Build 2023. My name is Cesar De la Torre. I work as Principal Program Manager at the organization named Microsoft Strategic Missions and Technologies in Microsoft Corp. And the session today is going to be about how you can, as a developer, develop modern connected applications that could be running on a 5G network or multi-access compute edge network. And then at the end, I will also talk about the future and orbital space. Okay, so starting from scratch, basically today or nowadays, like Microsoft's main streams are about these two areas. It's about ubiquitous computing, so the cloud, Azure, and putting all the computing in there, and it's going to be everywhere. And then also a very strong mainstream about artificial intelligence, right? But then our organization is focusing on what we call future of the cloud. And that means extending the connectivity to the ultimate edge. And that means also 5G and putting the compute and models at the edge, close to the data, where data is being produced, like in IoT, sensors, video. So everything is going to be more efficient. And then also even in the space, I will talk about that, and that's more for the future, Azure orbital space, okay? So we're going to talk precisely on the right side. So the edge and how you can create applications as a developer for that. So based on that, we think that there's a new application paradigm. It's what we call modern connected applications. And the key word here is connected, right? It's the connection. You could also call it like connected native applications, because it means that in this new world, the applications are going to be network aware, right? They're going to be able to talk to the network and change the conditions and service from the network depending on events or how your application is behaving, right? At the same time, of course, taking advantage of low latency and high performance at the edge, very close to the data or the video or the sensors, right? And once you have these, of course, you want to be able to deploy your application anywhere, on premises, on a private 5G, multi-access edge compute, or public MEC, or even in the cloud if you don't need super low latency, and even in the space, as I will talk about that later. So this is kind of the goal for you, like creating these edge applications or modern connected applications, right? But then these modern connected applications under the covers, because that's what you're going to create as a developer, as an ISV, as a company, you're going to create these modern connected applications. And under the covers, there are Microsoft products for instance, for the servers or appliances at the edge, like Azure Stack Edge, or products for the 5G network, like the 5G core, which is kind of the brain of the 5G network. And we have those products available today, so you can create a 5G network with Microsoft 5G core, or you can also use like mini data centers, which is a public MEC, so a low latency as well in the same city, and that's what I highlighted in there. And then more for the future in private preview, it's about the network APIs or Azure modern connectivity, Azure programmable connectivity, and Azure Space that I will talk later, right? So those are kind of the products under the covers. But what we're going to talk in this session is about how you can create your modern connected application from a development point of view as a developer, right? So then the question is, okay, how can get started creating that? Because the problem is that these kind of applications are, let's say, cloud native applications at the edge. So very much related to Kubernetes, event-driven applications, MQTT messaging brokers, microservices architecture, and then also usually AI video analytics or AI models, deep learning models. And, you know, being able to develop an application with all those topics and the right patterns and approaches and technologies, that's a pretty steep learning curve unless you are already familiar with cloud native applications or microservices and Kubernetes. So the question is how you can get started with that easily, right? So that's why we created this example application, which we call Multi-Access Edge Compute Application Solution Accelerator, which is, as I said, an example application, open source, that you can take, play with it, reuse the code, extend it, and create your own modern connected application, right? So once you take that code, because it's open source, like you'll be able to extend it and, let's say, create your own flavor for, let's say, an airports application, like a smart airport or a smart road application or manufacturing or any other industry that you work on, right? And of course, then you will create a production-ready application, because this is an application to get started. It's not like something that you just take and use on production. It's something to get started, to learn about the patterns, about the right technologies, and then you would create the code that would be production-ready. So if you think about a simplified architecture, in this case, using a 5G network, the upper area on the left would be the infrastructure that you need to run a 5G network with Microsoft Core, 5G Core, like Azure, using Azure Private 5G Core, in Azure Stack Edge, in AKS, and then integrated with a 5G RAN, and that would be transparent for you. It's like the infrastructure for the 5G network, right? But then what you would be creating is this application and services that you would deploy. I mean, it could be the same server, but usually in a different server, which is your application, your modern connected application. And this is what we're going to be talking about today, and about how to create these kind of event-driven and connected applications, and about the code. And of course, these could be extended with cloud services for the long term. But the focus of this initial version of the example application is just about the edge. So what's highlighted in yellow, okay? So that's the focus. The focus of the session is not really the infrastructure of 5G networks or the cloud. It's more about creating your application for the edge. And honestly, you could even run and try this application without 5G. Could be just a single laptop with any network, Ethernet or Wi-Fi. But we are focusing on this because of the many scenarios that 5G enables related to large areas and mission-critical applications with 5G. So going to this example application, these are the technologies that we are using to develop this example application that you can learn about. So basically, it's I'm not going to get into the details because I'm in the architecture slide. I will talk about that, but basically it's about Kubernetes or AKS, Dapper framework for building blocks, especially made for microservices architecture, public subscription, sidecar, containers, and so on. And then you'll see Python services for scoring or for inferencing with a model, deep learning model, and then other microservices using .NET and MQTT broker for messaging, right? So these are the technologies. And then I'm going to show you here the architecture, okay? So basically, you're going to have on the client side, you would have video cameras with RTSP's video. In the case that you don't have that, a camera could be 5G or could be Wi-Fi. If you don't have that, you can just put an RTSP simulation in a VM, or even in the code that you just get from the GitHub repo that you can see the URL up above. We have also an example video running within a container, so it'll work directly. But then you'll be able to change it, kind of the URL, and put your own RTSP video, right? So You are getting that video through any network. In this example, it's 5G, but could be any network. And then there's a microservice that we call frame splitter. Is taking that video, splitting in different frames, using Dapper for the communication, so we can communicate with gRPC very easily, or HTTP, but probably like it's better performance and lower latency with gRPC. So we will send those frames to the model, and that model is running another microservice, in this case Python as well, and then receiving all the frames, all the images, and when we detect something, like with object detection, we detect a person or could be anything, depending on your model, then you would generate an event. In the example, we are using a generic foundational model like YOLO, but you could replace that model with your own trained model for your particular use case. So once the model detects something, object detection, then the service generates an event, and that is submitted to this light event bus, which it's using a public subscription approach, right? And the important thing here is that it's using MQTT, so it's very light, very fast for the edge. It's not like when you're using a heavier event bus in the cloud. This is like it has to be light and fast with very low latency, right? So for now, we are using Mosquito, but then the important point is that we are using Dapper public subscription building blocks. So it's like an interface that we use, and so if we replace in the future this messaging broker with E4K, which is an MQTT broker from Microsoft, but it's like, let's say, an MQTT mission critical broker, but it's in private preview right now. But when it is in public preview, we'll just swap it, and we won't need to change any code at all because we're using this Dapper building block, right? So then that event is sent to the public subscription, and then you can receive that event from anywhere, any event handler. And what we're doing is we are getting that event and handling that event in a rule engine microservice. Basically, getting the event, okay, we detected something, maybe it's an issue, maybe not, and depending on your own rules, business rules in this .NET microservice, then we identify an alert, and then if it is an alert, then we submit it again to the event bus as an alert in this case, and that alert could also be consumed by any other endpoint. So could be, let's say, another machine that needs to react, or in our case, for example, we are getting it and put it in a database, so we then show it in a dashboard, right? And basically, you will see in that alerts dashboard the alerts being popping up, right? So that's the end-to-end architecture, and now we're gonna go and see it live and how you can also create it. First of all, I want to highlight where you can grab this example application or solution accelerator. You can go to GitHub, and you can see here the URL. Okay, so it's in GitHub Azure MEC App Solution Accelerator, and basically in the homepage we have an introduction. It's kind of many things that I'm precisely saying in this session. What is an MEC application or connected application, where you can deploy it. You can use production environment in Kubernetes, or you can also use Docker, plain Docker host, and also Visual Studio for developing. So, and then an overview of the architecture that I just explained, different architectures, and if it is more or less heavy edge use, and finally, you can deploy it on the different versions that we tested of Kubernetes, like AKS Edge Essentials, which is a new version or flavor of AKS for the Edge from Microsoft, or you can try Kubernetes from Docker Desktop or Minikube, or you could also deploy these into the cloud, into AKS in Azure. Could be a regular data center, or could be a public MEC, which is like a mini data center from Microsoft, right? So And you can see here, for instance, if I go to the deployment of AKS Edge Essentials, like all the steps, how you can deploy the application and check the application in Kubernetes, which is what I'm going to do now. Okay. So basically, the first thing I'm going to do is, I'm going to run this application in Docker host with Docker Compose app. You see that it's creating all the containers. So it's going to take just like a few seconds. And basically, you would use Docker, plain Docker, when you are developing your containers, your microservices, because it's a lot easier to debug your code. And then you can run it with Docker Compose app, or you can also run it with Visual Studio and put breakpoints and do debugging. Okay, so once you see that it's sending here different frames, then the application is working. I can also see the containers running here, but basically I could go to this URL now that I already had it. And you will see the different alerts coming here, right? So this is the alert, the URL, and you can see that when I click to any of the alerts, I can see the detection of a person in this case, right? So it's that easy. Like you just do git clone, get the repo, and then once you have the code, just go to the root folder and do a Docker Compose app, and it should be working. Or you can also do it with Visual Studio, as I will show you in a minute. I'm gonna do a Docker Compose down now. You can see that we shouldn't have now in a minute most of the containers. So the next demo I'm going to do is precisely talk about the code, right? So if I come back to the architecture, basically this is the first microservice where we get the video, and we are going to be sending that splitting the video in frames and then sending the frames to the model, right? So how are we doing that, right? So just while doing that, just Docker Compose down. So with Visual Studio Code, here we have the frame splitter, right? That's the first microservice. And basically what I want to highlight, in addition to the boilerplate code about getting the images, is when we are using Dapper client to invoke the next microservice, the model, and using client invoke method. And the interesting thing here is that you can invoke using either HTTP or gRPC for better performance transparently, because when you are using Dapper, you can see here Dapper annotations where we say, okay, because the communication is going through the Dapper sidecar container instead of my own container, I can say use gRPC for the communication or use HTTP, right? So just by doing this, when I send these images to the model, that's going to use gRPC, which is a better performance, lower latency for my application, right? So once we are invoking that service, now we are in the model, right? So the model will be detecting with object detection issues. And then once we get that issue, we will use a asynchronous communication submitting an event to the broker, to the messaging broker or light event bus, right? So the way we're doing that is with the inference model. You can see here that, well, let's just go to main, like we are getting the image. You can see, and the then using the model. And once you get the model detection, you can see that we get bounding boxes, like where was the detection done. And finally, we publish that event. Okay, so maybe we detected a person, right? So we publish that into the broker. But again, we're using Dapper for this. So it's very easy to do it with this client publish event. And today we're using Mosquito as a messaging broker. But if we are swapping Mosquito with E4K from Microsoft in the future, I won't need to change anything here because we're using the public subscription Dapper building block. So that's this would be transparent. I won't need to change this code, right? And something else is that when we send that event, we are also using a particular schema based on Avro and the Avro JSON serializer. Why? Because potentially you could also submit this event to the cloud through Azure Event Hub, and then for aggregating or retraining or getting all the long-term events. And you would need to have like a particular definition of the schema of the event. So we're using Avro for that, and that plays well with Azure because in Azure you also have the Azure schema registry that is also using Avro for those events, right? So that's why we are serializing these events based on a schema with Avro, right? So that would be until this point, we are sending this event, and now we can grab that event from another microservice. In this case, it's in .NET, and what we're going to do is, okay, we detected something, but is this an alert or is just an event that I need to discard? So you need some business logic to know that, and that's why we created this microservice, which is a rule engine, and that's in Visual Studio. So I mean, in .NET. So in this case, I'm using Visual Studio for showing the code. And by the way, if you open the solution with Visual Studio and you hit F5, then you could debug all the different microservices from Visual Studio, right? But if I go to this specific .NET microservice, the alerts rules engine, here we have the event handler. So when we get an event from the subscription just by simply using these attributes from Dapper. You can see that I'm using the topic in the public subscription new detection, and then we are deserializing the event with Avro. And once I get the event, I send it. We are using a mediator internally in the service, but it will send it to the public subscription. And then finally, if we identify that it's an alert, then it will submit it, right? So in here, we have this another service, which is sending the event internally, but then it will be sent to the public subscription, and another microservice will get it. And in this case, we're just putting that in a database and showing that in the dashboard. Okay, so that's what I wanted to highlight about Dapper and the most important areas or lines of code. Now I'm gonna show you another demo, which is about Kubernetes. So because until now we were using or developing these containers in Docker, but when you move to production and you want to scale out and create multiple instances of the containers, you need to use Kubernetes, right? So when you deploy this into Kubernetes, it's as I mentioned, we have documented how to do it, as everything, all the steps about installing the Kubernetes cluster, Dapper, and so on. But then finally, it's just this one single command, how you deploy it into Kubernetes. So I already have it because it takes a few minutes. So I already run this line of code of command. So kubectl apply and all these different configuration files for Kubernetes. So it's already deployed with this single line of code. Single line of command. So if I go to Kubernetes, I should see it. So here is the dashboard. I need to put a token to get into the Kubernetes dashboard. So let's put it here. And now I need to select in what Kubernetes namespace is my application, because it's not in default. We put it in a different namespace, which is MEC accelerator. And you can see here that it's deployed, up and running, all the different pods. We could see, for instance, all the pods. And you can see that for each pod, we have 2 containers. One container is my own container, my code, and the other one is the Dapper container, the sidecar container, which is taking care of all the communication, right? Except, of course, the containers that are infrastructure, like MongoDB or the Mosquito pod container. But the rest, where we are using Dapper, we have 2. And then if we go to the services, you can see here that the alerts UI, this is the dashboard of the application, the UI of the application. Here we have the IP, and I can click in here and see the alerts dashboard. In the same way that we could see it in from Docker, but now this is running in Kubernetes. And you can also see like the different detections or alerts coming. Okay. So that's all about Kubernetes. I mean, there are more things that we could be talking about, like the Dapper dashboard and things like that. But the most important areas are these. And finally, I want to talk about what's about the future for this application, and also Microsoft technologies. So in this application, as I was saying, we have this application running at the edge, or MEC, or multi-access edge compute. In the future, we could also extend it to the cloud. So basically, instead of just having these events and alerts locally in this local dashboard within the edge network, we could also be sending all the events and all the alerts to the cloud through Event Hub, through Azure Event Hub. And that would be very easy with E4K and the connector through Kafka, because then it would be automatic, or let's say without changing anything. We could plug it, and then we would be getting all the events in the cloud, and we can do, I don't know, like aggregation of the different sites, or we can do model training with all the data that's coming. We could also be sending all the images, kind of a long-term data analysis and aggregation, right? But today we have what you see on the left in this example application. Additionally, and this is very important, and that's why we are talking about modern connected application, is about making the applications network work. And that's going to be possible with Azure programmable connectivity. Because today, in the version that we have, it's just the application, but the network is kind of transparent. Could be 5G, could be Wi-Fi, could be Ethernet. But if you are using Azure programmable connectivity APIs from your application, you'd be able to say to the network, hey, I have a spike of usage, and I need a better quality of service. I need better bandwidth. I need better latency. So give it to me, right? So with this API, you'll be able to talk to the network and change the behavior of the network, not just in 5G, but also related to other networks about, okay, I have my application maybe deployed in the cloud in different places or in different areas. When I deploy this camera, where should I pair this camera to this deployment or this other deployment in a different site or a different country? So that can be also kind of detected by Azure Programmable Connectivity. So Azure Programmable Connectivity, it's in private preview, so that's why we still didn't put it in this example. But like I mentioned, and I'm not going to go through all the features, but the most important things are the fact that you can discover different, not just clients, but also the MECs or the applications on the network, and say, okay, if I have like my application deployed in 3 different Kubernetes and different places, and I deploy a new camera, I could say, where should I pair? So I send the video to the right or closest deployment of my services, right? Or, like I mentioned, you can also configure quality of service between the client and the server if you want to ask for lower latency. This platform, Azure Programmable Connectivity, is not just something from Microsoft, because the network, in most cases, for instance, if we're talking about 5G, are going to be from operators. So under the covers, it's kind of aggregating the network APIs from operators, like from AT&T, Telefonica, and Deutsche Telekom, Singtel, different operators, and put in a single interface. So developers would have a single API for doing this, right? So that's one thing that I wanted to mention. And then the other important thing about the future, it's Azure Orbital. And Azure Orbital, maybe you have heard about it, and of course it's logical or something that you can do, which is you have your application somewhere where you don't have internet or you don't have connectivity to the data center or to the cloud, and then you can use it for connectivity, right? Just with an antenna connected to the satellite, and then the satellite connected directly to Azure Cloud, so that without going through internet, so it's a good latency. But that's not the main point I want to highlight here, which is Azure Orbital Space SDK. And this is a different feature where for developers, where you can deploy your application in Kubernetes in the satellite itself. Like if you had a server attached into the satellite with Kubernetes, right? And this is what is Azure Orbital Space SDK. Basically, you'd be able to deploy your application, like we were seeing your application with Dapper, Kubernetes, in this case, like K3S, because it's lighter. And then the important thing here is that you'll have access to the satellite sensors, like the pictures coming from the satellite, etc. Right? And this is great because then, like, you would have the AI models up in the satellite and then processing all the images taken by the satellite and only sending back to the Earth when you detected something, instead of sending all the images taken. So it's a lot of value for efficiency, right? And then this SDK, what it's doing is that it's providing like a simulation of the satellite. So you don't need to have a satellite in order to create your application. You just use a simulation with the application kit and a VM, and then you can develop your application, and only at the end of the project, you deploy it in a real satellite. So this is Azure Orbital Space. It's in private preview, as I mentioned, but it's very much related to these modern connected applications being deployed in the space, in the satellites. And that's pretty much what I wanted to cover. Here are the call to actions. You can grab this example application, the MEC Application Solution Accelerator, which is open source from GitHub. You can fork it. You can create your own flavor about your own industry. Please feel free to send back feedback as issues in the GitHub repo, or you can also contact me by email. And of course, you can contribute to improve it with your own PRs, with pull requests. Also, you can download these 5G use cases documents. This is about 5G when it makes sense to use 5G. For instance, for smart roads or smart airports, smart factories, like large areas. And these documents are these that I have in here. Basically, we have like one related to the business value for that scenario and that use case, and other technical documents about the architecture and different scenarios. So this is more about the opportunity of the scenarios. You can download it and read it. And then another thing that we are creating is a 5G starter kit, because if you want to try your application not just on your own laptop, but then see how you can it's working with, let's say, a 5G camera, and you want to have like a 5G network, you need the devices, the 5G RAN, the Azure Stack Edge with the 5G core. So we are creating with a partner a kit with all that hardware, the minimum cost possible for developers, and you can contact me for that. That's coming soon. And then about Azure Programmable Connectivity and the Orbital Space SDK, as I mentioned, they are in private preview. You can send me an email and you can enroll in those, right? And also we have a newsletter about model connected applications being sent once monthly. So you can also subscribe in there. And yeah, about all these call to action points, feel free to contact me to my email, cesardl@microsoft.com. And that's pretty much it. So let's here you have my contact and my email. And thank you very much.